a genuine pleasure to be able to speak to you this morning. And my goal today is just to get you to think a bit about the issues of climate change, our response to, of course, cutting emissions, but also the risks of climate change itself. So I'm going to try and give you an unusual presentation. I don't often get the chance to do it. I was thinking about what I would talk about, and I thought I would take this kind of slightly divergent way. So unusually, I'm going to talk first about climate risk, and then second about decarbonisation. I'm doing that deliberately because I think that you as innovators, engineers, academics, I would like you to think about these challenges together, because I think actually that is going to be a bigger and bigger challenge overall. So hopefully you agree with me at the end of this presentation. So let's just get going on that, just to give you a sense of how urgent this climate crisis really is. I use that word crisis deliberately because I think that's what it is, but it's a strange crisis because we don't experience it as we would normally experience an imminent crisis. That's one of the problems, is you therefore need economics, politics to come together to act on it. And of course, that's always a challenge. This is why I think it's a crisis. This is a representation of the concentration of carbon dioxide in the atmosphere over 800,000 years. We have that information because we can look at the bubbles trapped in ice at the poles. You see this very clear carbon cycle over the last million years or so. If I just plot onto that what's happened since the Industrial Revolution, it takes us right up to date, just up to, I put this chart together just last week, in fact. So this is CO2 readings from the observatory in Hawaii that takes them well over 400 parts per million. That line is pretty remarkable. You can see something pretty strange has happened in the last 150 years, especially in the last 50. If I tell you that the temperature on the surface of this planet is related in a near linear way to the concentration of carbon dioxide in the atmosphere, then this should trouble us all. We are, I'm afraid, now in uncharted territory, certainly as a species living on this planet. But the planet's been here before, probably 2 or 3 million years ago. Back then, the world was a lot warmer, so the seas were perhaps 20 meters higher than they are today, the last time the world was at these kind of CO2 concentrations. So that kind of red box there is telling a story really of a profound influence that we as a species living on this planet have had on the planet and the temperature on it and the climate of it. We are warming the planet, and we can actually see that from observed data. Here is the temperature change, the global temperature change expressed in color against an 1850 baseline. So red for increases, blue for decreases. And hopefully you can tell the story that's playing out now because of that line that I've just shown you. It's driving major change in the climate. It's driving major change here at home in the UK as well. So the 10 warmest years in the UK have all been since 2002 now. 2020 was, I think, the 3rd warmest year. So you can see there's a pattern emerging, starting to see some signs of climate change and other things like heavy rainfall as well going with that. So that's where we are. And I kind of wanted to just kind of give you a take on that, because it will matter immensely to the energy system and energy technologies. And I just like another take on it. I've got a couple of ways into this, just to see, have a look at the climate impacts that we are now experiencing here in the UK. So in this first column, this is what we're seeing now. Remember the 2018 summer heat wave that we had? Well, that's now 10 to 25% chance each year. It was below 10 just a few years ago. I don't mind saying I was born in 1978. We have warmed the planet since the Industrial Revolution by between 1.1 and 1.2 degrees centigrade. Half of that has happened in my lifetime. So the challenge now is really accelerating, and it is going to be a factor in some of the things that we talk about in just a second when it comes to net zero. In the second column here, this is the change that we expect in the UK by 2050. And I'm afraid most of this is now locked in. So 2018 summer heat wave is now 50% chance each year. When we look at where we are in 2050, that will be a usual summer. You can start to see, hopefully on this, the kind of fall in summer rainfall, which will affect things like hydro availability, wetter winters, tougher storms, heavy rain up to there too. Just think about the storm we've just had. That's the kind of impact we'll see very frequently by 2050. I'm afraid most of the progress that we might make globally on emissions will only have an impact on the climate after 2050. So let's just look at that now. And just now's the time, I think, to bring in COP26 that we've just had in Glasgow. as we leave COP26, realistically, the world is facing, if you add up all the policies that we see globally, the world is facing realistically a temperature increase of 2.7 degrees centigrade. Remember, we're about 1.1 at the moment by the end of the century. That is pretty catastrophic. It's progress from where we were prior to Paris. We were facing something like 3.6 degrees centigrade by the end of the century before we had the Paris Agreement in 2015. And that is very troubling. But I think crucially, there is a path to something lower than that now, possibly under 2 degrees centigrade after COP26. That relies ultimately on everything that was brought to Glasgow being delivered. I don't have full confidence that we're there yet, but that kind of introduces this idea that we need to think about a range of temperature outcomes. So you can think, you're academics, you're innovators, you're engineers, you deal in risk. In risk terms, the temperature projections are between now, I think, an optimistic 2 and a pessimistic 4, given all the uncertainties of delivering these emissions reductions that we have seen discussed at length at COP. That gives you this sense. So these third and fourth columns you can see here. You can see much warmer temperatures, greatly increased chance of summer heat waves, of course, drier summers, wetter winters, much higher seas is another factor. Think of all the energy infrastructure we have at sea level globally, and even in the UK at the moment. So I wanted to bring you all this because it's a real thing now. It's not some vague concern for the future. Really, I think does have to be factored into the planning that we do for our energy systems, for our economy in the future. It's fundamentally a big engineering challenge as well. And we're going to have to tackle that. Just to give you another sense of a final thing on this, just when we talk about those risks, it's often easy to talk in averages about some of these things, and the averages are pretty horrific, but actually the impacts of climate change ultimately are local. This is just looking at one aspect of that, and it's a particularly striking chart. So this is, again, our 2-degree world and our 4-degree world that I was talking about. Look at the size of the UK in that 4-degree centigrade world. Just utterly dramatic changes in the kind of conditions we'd experience on a hot summer's day. Think about the impact of that. If you look at that 2018 summer heat wave I was talking about, we saw in that year 1,000% increase in gorse fires prior to the year before, in comparison to the year before. Almost 1,000 heat-related deaths that were reported. There were almost certainly a lot more than that. We had overheating happening in hospitals. We had emergency call-outs for private water supply failures. We had subsidence claims rising by 10,000 in that year. 40 to 50% increase in rail asset failure. Loads of that. I could go on. 7% reduction in hydroelectric generation compared to 2017. I just wanted to say all that because I don't often get the chance, but I think you need to think about this when we come on to the challenge of what we actually do about all this. Net zero is, of course, what we need to be focusing on. It is an enormous challenge for energy, but we also need to think about achieving net zero in these kind of climatic conditions. So I wanted to make that point to get you to think, really. But that's where I want to go next, is the challenge of what we do about net zero. This is the kind of real bread and butter of my job in the Climate Change Committee. We try to build detailed, integrated models of the steps that we need to take across the economy in the UK to achieve net zero. That's mainly through building sectoral models and adapting those sectoral models to technology change as we know it. It's a fascinating thing to do. I absolutely love my job. Not least because it gets you into such profound discussions about what we are heading for as a society and an economy. So let's get into that. This is the kind of key chart for the UK. This week, I've been talking mostly about Scotland. I'm back to the UK in this chart. In black, you see the historical territorial emissions in the UK, which have been coming down. In purple, the recommended path that we built for the UK last year, which has now been turned into a set of legislated targets for the UK. The most recent of those is the orange box there, which is the 6th carbon budget for the mid-2030s. That's the amount of greenhouse gas emissions that can be legally emitted in any 5-year period. So that's just been put into law. You see also the 2030 NDC, as it's known. That's the target for emissions that was submitted to the UN process. It was also drawn on the path that we generated for the government last year. The impact of that is that we will have to cut UK emissions by almost 80% by 2035. Worth saying that used to be the 2050 target. So this is a big step forward in terms of ambition. The path that's there in the dotted line is a really interesting one. It's inverted S shape. Hopefully you can see that. That's because in the early years, we're kind of having to scale up lots of sectors that haven't been deep inertia in doing that. So you get this sort of plateau effect. Then, as we get into the 2030s, all of that policy making starts to have an impact, and we start to switch to this kind of asset turnover happens in the economy as we switch to low carbon devices and technologies across the economy. You get this much sharper emissions reduction, which tails off towards the end by 2050. If you live in Scotland, as I do, 2045 is the net zero target that we have. That's exactly the same basis as the UK 2050 one. It's actually the same target. To get to 2050 for the UK, that Scotland will have to get there slightly earlier. So I know many of you will be in Scotland. Those two targets are wedded together. But that's the kind of overall challenge. It's a big challenge because we've almost done on the story of decarbonising coal, taking that off the system. We've got these much harder challenges outside of the electricity system. So just to give you a sense of that next, this is the kind of rainbow chart of abatement that we built in one of our scenarios, the one that we recommended path, the balanced scenario as it was called. The black line at the top is what happens if we could turn off climate policy today. You'd get this kind of steady increase in UK territorial emissions as our baseline. The purple line at the bottom is that path we've just talked about, the dotted line. And what's between that is the kind of stripes of abatement. And they're really interesting. And I think another way to get you thinking, the top stripes are demand reduction and energy efficiency. That's things like home insulation. That's doing quite a lot of work in the early years. So, and not strongly targeted by policy, sadly. So that's a kind of interesting thing to discuss. The red, the orange, and the yellow, hard to say that this time of the morning, are all adopting, where we're adopting low carbon technologies. That's that story of asset turnover I just spoke about. This is us moving to electric cars, to heat pumps, to hydrogen technologies, a bit of carbon capture in there as well. We haven't finished decarbonising the energy system, so that blue stripe is us doing that, the last kind of abatement on energy. Worth saying that we've got to do a bit more than just abate it. So we've got to actually hugely grow the size of the energy system for low carbon energy supply. And we'll talk about that in just a second. But that blue line is energy. That allows us to have a fully decarbonised energy system for those devices that I've just talked about that use it. And then the last bit is the green bit, which I'm not going to talk too much about today, but that's the kind of net in net zero. So that's what we're doing in the natural world to store carbon. That gives you a sense, I suppose, of the overall challenge. The kind of main thing here is asset. That and just towards the end of my talk this morning. But I think the key thing to know is that what's driving the emissions that we have is the fact that we use fossil fueled assets and technologies. If you buy one of them today, a car or a boiler or a piece of plant machinery in industry, it will have a useful economic life of between 15 and 20 years on average. So just think that through. What we need to do is to stop selling those assets. If we want to get to net zero by 2050 or earlier, we've really got to stop selling those assets by 2030. So actually that for me is the challenge, is that over the course of this decade, we've got to scale up the policy so that we're ready for that switchover from 2030 onwards to get this kind of outcome. So just moving on then, what's behind that story is a story of fascinating set of stories actually in each of the sectors of the economy, which is built from, in our modelling, a set of very distinct sectoral models. We integrate those sectoral models. And I'm showing you this not because I'm going to go through any of these lines in detail, but just to say that we haven't just kind of got our big pen out to draw you that S shape I talked about. There's a kind of a story of integrating and building up these stories in every sector, putting policies in place, building supply chains, stimulating the investment, as I talked about. Crucially, it's about deployment in the end. So scaling that up when it's practical to do so, so that you get to net zero on time is the central challenge, I think, in all of this. It's a massive undertaking. I just wanted to highlight just a couple of those lines. So if the story of progress in the last 20 years has been about how we've been decarbonising power, lots more to do on that, of course. I'm sure you've been talking about that in the ETP. But the two main challenges for me that we face over the next 20 years are fully decarbonising buildings and fully decarbonising industry. Buildings is the big political battle. Every journalist loves a story about gas boilers, of course. Really important to say that no one is going to come and rip out your gas boiler yet, but we do need a plan to replace high carbon heating with low carbon, also to make housing and buildings more energy efficient. That is a big challenge. We haven't got an answer to that just yet. It will bring in heat pumps, of course, but also district heating, low carbon heat networks, and possibly hydrogen. Interesting, we're not short of options across these things. What we are short of is plans and hard commitments. So that's going to be the political space, I think, that we're in. Industry is the other biggie. Our outlook on industry emissions has changed hugely since our last UK assessment, which when we made that 5 years prior. If I tell you that 5 years ago we had our recommendation for 2030, and 5 years later we've just made that recommendation I talked about for 2030, it's changed enormously, and 75% of that change in the 2030 target we recommend is accounted for by industry emissions, what we call manufacturing and construction in this line. So that's because we've tried to build a fundamentally different understanding of what can be done to decarbonize industry through fuel switching, through carbon capture at the margins, of course, but crucially early investment so that we catch asset replacement cycles early. Otherwise, this looks like a hard to abate sector in the round. It's also now the front line of climate policy. So emissions trading schemes, carbon taxes, trade policies, carbon border adjustments, all of that is kind of in the mix now. Fiscal policies for fuel switching, that kind of stuff. Really interesting. I think that's going to be, the other big challenge coming up. So just a couple more things to get you thinking. I'm going to whistle through this, but you are energy. You care about energy, as do I. And the challenge on energy is, either enormous or awe-inspiring, depending on your outlook on it. I'm definitely in the latter camp. Here's a little mission statement for you, drawn from our central scenario for the UK to get to net zero. We need to take UK energy demand from about 2,000 terawatt hours today. So that's 300 electricity, 1,700 oil and gas. We need to have that energy demand by 2050, taking that to 1,000 terawatt hours, and then change the mix utterly so that 1,000 is made up of 700 electricity, 300 oil and gas by 2050. About a fifth of that is going to be 1,000. Will be hydrogen. About a fifth of that 1,000 terawatt hours is hydrogen. So that's, in our view, what must be done, or rather, what can be done. Just to give you another set of stimulating charts to get you going on that. I'm going to look at how that plays out on the demand side. There's another set of charts I could show you on the supply side, but I won't do that today. I'll just look at demand. Stunning change in electricity demand happens over the course of the next 30 years. Growing by a half by 2035, more than doubling by 2050 to replace most of the oil and gas demand that we have today. Our balance pathway reaches 80% of the supply for that demand from renewables, mostly offshore wind, about 100 gigawatts of offshore wind by 2050 in our central scenario. Plenty of space for seabed capacity to do all of that. Nuclear is in there. You can see hydrogen in there too. It's a huge step forward on electricity, and it's probably the biggest challenge of all, of course. Natural gas demand then, of course, falls by about 3/4 from today. More renewable electricity, more electrolyzed hydrogen means less reliance on gas that with carbon capture and storage than we've had in previous assessments. By 2050, really, all that's left in gas is being used with CCS for power generation, for hydrogen production. Oil demand falls rapidly, about 85% reduction in oil demand. It's really just jet fuel by 2050, but really striking shift there. Now onto the kind of low carbon energy fuels and carriers. This is hydrogen demand. We see a very high, sizable hydrogen sector develop. We're growing it from almost nothing today to something that in terms of energy output is about 2/3 the size of the power system today by 2050. Mostly that hydrogen in our assessment is being used in manufacturing as a replacement for natural gas, also in shipping, probably as ammonia. We expect the main source of that initially to be blue hydrogen, as they call it, with an increasing role for green hydrogen as we grow the size of the renewable electricity system over time. And just to stick with hydrogen, because it's such a vexed topic now, kind of new format wars, just to say that in terms of the possible uses for hydrogen, we do have several scenarios. And I wanted to just show you that. This is an assessment of how demand varies across those scenarios for hydrogen. To put it mildly, views differ on this. If you just look at that question of whether we'll use hydrogen in buildings, we have one scenario where it's supplying 11% of homes, another where it's supplying 71% of homes. So it's clearly something needs to be resolved there over the course of the next decade and beyond. And then the last thing here, another of the controversial topics, is on carbon capture. Black section here that you can see is BECCS. That's us combining carbon capture with bioresources to get negative emissions, which we definitely see as credible if we have the CCS infrastructure in place. We would expect that to be paid for by those sectors that are still using fossil fuels, especially aviation. Purple section here is hydrogen production. I talked about that's the blue hydrogen production. You can see that that's starting to come down over the 2040s. But the main thing here is just huge changes and a huge new market for carbon capture that largely doesn't exist at all. I just think in general, this is a huge moment actually when it comes to anyone who's working on energy across this challenge of net zero. Massive challenges ahead, but hugely exciting to be around it. I hope you agree. Now, that's where we are on energy. I just wanted to say one more thing on the cost of all this. We see a really huge investment challenge for the country, but one that is entirely achievable, we think. Overall, we in the CCC reckon that for the UK to get to net zero, we're going to have to scale up investment to an extra 50 to 60 billion a year across the economy by 2030. The government in Westminster agree with us. They said 60 just a few weeks ago in their net zero strategy. So broadly consensus now on this idea that investment is going to drive this, that we need to scale up investment across the economy. That is the policy challenge for the next 10 years, is to take it from the 5 to 10 that we spend at the moment, mostly in the renewable sector, to something more like 50, 60 by 2030. Then we maintain it. The interesting thing in this chart is that investment you can see is being driven by these 5 things. So it's the transport system, the cars, the electric cars, the charging, of course, buildings, as I mentioned, electricity supply still enormous, and the networks, the energy networks that will support all of that. And then, of course, the 5th thing is the industry investment to decarbonize industry. That is a lot. So it is adding about 1/8 to total investment that we were doing prior to the pandemic. It is, because it's a lot, it's also a major shift in economic policy. It could potentially bring a big boost to GDP if there's spare capacity in the economy. Lots of extra jobs in some sectors. We reckon there's 200,000 extra jobs in that challenge of building retrofit alone, just to give you a sense of that. Lots of big opportunities in developing new industrial opportunities for the economy as well. But it's a lot. And if that were just a cost, then it would be quite a big cost for the nation to swallow. But it isn't. And this is my final slide. That's because all of that CapEx has an OpEx benefit. In investing in these low carbon devices, many of them electrified, we're becoming much more energy efficient across the economy. Think about an electric car, for example, how much more efficient it is in its use of energy. The power for those electrical devices is going to be cheaper and cheaper if it's based on an idea of a kind of flexible energy system that is principally drawing its power from offshore wind or renewable technologies where you've got zero marginal cost. If you add all that up, you get this OpEx benefit, which you see under the line. This is the saving to the UK economy from using those devices, and I suppose from not importing expensive fossil fuels. And it's a very significant saving which grows over time, principally at the moment in the purple wedge that you see in surface transport. That's because of those electric vehicles principally. But when you net those 2 things off, you get actually a very low overall cost, an aggregate cost to the economy of achieving net zero. And this remarkable figure, which I stand by entirely, that the cost is now in aggregate less than 1% of GDP in each year. So to put that in more straightforward terms, that means that we would get to the 2050 GDP level that we would have reached without net zero about 4 months later. So just think about that. It's a 4-month delay over 30 years to fully decarbonize one of the biggest economies in the world. Clearly worth doing, I think. You can disagree, but I certainly how I feel about it. And that's also a conservative assessment because we see lots of potential for that net zero investment to actually drive the economy in the way I described. But of course, the last thing I'll say is that masks the more challenging story underneath this. We have to be honest about this, that no one experiences an aggregate cost. So there are real costs here, notably in the cost of buildings and industry. People will feel those costs. They are not if they're not protected from them by policy. And in other areas, there are real savings, notably that surface transport transition. You need to capture some of those savings to help pay for the cost somewhere else. So massive challenge here, which is, I think, principally a policy challenge. And standing back from it, perhaps to think about last thing I'll say is that actually, if the overall cost of this isn't the challenge, then the challenge, therefore, is actually to do this in a fair way, spreading those costs and spreading those benefits in a fair way. And I think that is also something that I would ask you to think about in the challenge of innovating around all of this too. We can't ignore it. But I'll end there, Steve Mark, and I hope that was a useful session for you this morning.
Yes, thank you very much, Chris. That was great as usual.